The rising global population threatens food security, as the increased demand for food puts pressure on our agricultural resources and production systems. This increased demand intensifies problems like land degradation, water scarcity, climate change, and competition for arable land, making it harder to provide nutritious food for everyone, especially in areas already experiencing food insecurity. Focusing on innovative technologies and sustainable agricultural practices, these challenges can become valuable opportunities that can drive economic growth and technological advancement. Research for Development, or R4D, plays a pivotal role in addressing the challenge of food security. In the Philippines, an organization is emphasizing the transformative power of technology to drive the sector towards its optimal potential through Research for Development, or R4D. The Department of Agriculture, Bureau of Agricultural Research, or DA-BAR, supported by various executive orders and Republic Act 8435, also known as Agri-Fisheries Modernization Act, or AFMA. DA-BAR is mandated to ensure that all agricultural research is coordinated and undertaken for maximum utility to agriculture. DA-BAR coordinates, integrates, funds and manages the R4D system in the country to optimize its use for the sector. It is envisioned to be the lead R4D coordinating agency, promoting a technology-empowered agriculture and fisheries sector that contributes to inclusive growth. To ensure that research leads to desired results and long-term impacts, DA-BAR follows the R4D Impact Pathway Framework. It assists DA-BAR in planning, monitoring, and evaluating the effectiveness of R4D projects under rice, corn and cassava, livestock and poultry, fisheries and aquaculture, organic agriculture, climate change, biotechnology, support to technology commercialization, agri-fisheries technology business incubation, and scale-up, thereby connecting research outputs to outcomes and societal impact, aligning efforts with industry goals, and generating meaningful, measurable change. It is DA-BAR's responsibility to ensure that suitable technologies and interventions are promptly accessible for the sector's utilization. However, DA-BAR cannot accomplish this alone. It needs capable partners in cascading these R4D outputs and outcomes that will advance technology-driven agriculture and fisheries sector. Collaboration is the backbone of research, and seamless integration of interdisciplinary expertise and resources is crucial for achieving common goals. By partnering with DA-BAR, we attain greater productivity in a cost-effective manner. Like the age-old adage, the sum is greater than its parts. Here at DA-BAR, we firmly believe that the power of collaboration has the potential to unleash a magnitude of possibilities beyond measure. We offer funding opportunities that can substantially improve the effectiveness and breadth of research endeavors. We facilitate networks and linkages to enhance opportunities to leverage expertise and resources. And more significantly, we serve as a hub for invaluable knowledge exchange, harnessing emerging and innovative technologies to tackle pressing sectoral challenges and global issues.
To the Department of Agriculture family, to our colleagues in the Bureau of Agricultural Research, sa ating mga magsasaka at mangingisda, isang magandang umaga. Ako po si Christina S. Estrada from the Knowledge Management and Information Systems Division of the Bureau of Agricultural Research, and ako po ang host and moderator natin today sa ating seminar. First of all, we would like to welcome you to the first episode of the online seminar series this 2026. So we know that New Year was already over a month ago, but we would still want to welcome you. And speaking of New Year, we for sure we already have our New Year's resolutions kasi we are so full of hope. Gusto nating i-develop ang ating sarili, perhaps expand our horizons as well. And often we associate New Year with development and advancement. Ako personally, lagi kong naiisip ang technology when we talk about New Year talaga. And I have always been very curious about artificial intelligence. But then, nasa DA tayo ngayon. And often we think of agriculture as something that's so primitive, so manual, na parang it also gets intimidating. But then agriculture is very basic because we can't survive without it. So now, what we are going to talk about today is how we marry something so advanced, such as the AI, with something that's so fundamental that we can't survive without it. So we are talking about agriculture and food. So today we will be talking about artificial intelligence in agriculture and the food industry. And this episode has been possible with our partnership with the Advocates of Research and Innovation in Agriculture Incorporated, or the ARIA. But again, we before we introduce our speaker and formally start the knowledge sharing, we have four reminders. One, comment your location and affiliation po para alam natin kung hanggang saan ang naabot ng ating serbisyo sa bar. Two, please follow our social media pages. So on Facebook, it's facebook.com/DEBarOfficial or search yun lang, DE Bureau of Agricultural Research. Then on YouTube, it's DE Bar Official or youtube.com/@DE Bar Official. So if you want to revisit past seminar episodes and other materials that we have, check nyo lang po ang aming YouTube account kasi specifically for live videos, tinatanggal po ni Meta yan on Facebook within 30 days. And yun. Also, third reminder, may isang form lang po kaming ipopost, the attendance sheet, and we will be posting it right before the lecture ends. So usually within the last 10 slides. So you have to answer it for certificate. So around 11:30 lang siya or 12 noon at most. And lastly, and most importantly, maximize po natin ang presence ng ating resource speaker kasi hindi siya laging andito. So without further ado, we will be meeting our expert in a moment. He holds a Bachelor of Science in Agricultural Engineering, graduating cum laude from the Visayas State College of Agriculture. His advanced studies include the graduate diploma and the postgraduate diploma in computer studies from the Western Australian College of Advanced Education, as well as a Master of Applied Science in Computer Studies at the Edith Cowan University. He further pursued doctoral studies in computer science at the De La Salle University and information technology at CIT University. His studies were supported by various scholarships and awards, such as the COCOFED Scholarship offered by the Coconut Federation of the Philippines, Colombo Plan Scholarship by the Australian International Development Assistance Bureau, the Mashav Scholarship by the Department of Foreign Affairs of Israel, and the Visa GTZ Scholarship by the Philippine-German Environmental Program. He is a licensed agricultural engineer and holds licenses on International Computer Driving License, PhilNIT's Fundamental IT Engineer Examination, and Certificate of Proficiency in Computer Programming, EDP Specialist Eligibility. Throughout his career, he has pioneered numerous IT systems across various institutions, including those that directly impact the agricultural and food industries. Notably, he developed 3 systems with a software copyright under his name. These are the plant leaf area calculator using image processing, rice leaf colorimeter using image processing, and plant close canopy area calculator using image processing. He is a retired professor at the Visayas State University, where he headed the university's Department of Computer Science and Technology at the College of Engineering for 14 years until his retirement. He is also currently an independent consultant which includes a consultancy with the DA Bureau of Agricultural Research. A distinguished academic and innovator with a career spanning over 4 decades at the intersection of agriculture and information technology, let us all warmly welcome Mr. Winston M. Tabada. Good morning, Sir Winston. Kumusta po kayo sa Region 8 ngayon?
Yeah, good morning, Christina. Uh, med- Medyo masama ang ano dito ngayon. Parang darating yata si Basyang within the day. So medyo
So,
kaya minsan napuputol din yung internet natin connection.
ayun.
So far,
Thank
yeah.
you, sir. Thank you, sir po, sa pagpa-unlock pa din sa amin. Signal number 2 po ata kayo. Ano?
Oo.
Ayun. So, to our audience, to our participants, ano lang po, parang just a disclaimer, there's a possibility na with the inclement weather, baka magkaroon tayo ng problems with connectivity on SIRS. But hanapan po natin ang paraan para matuloy at matapos ito. So, yun lang po. So, sir, alam ko po madaming excited sa discussion natin ngayon. In fact, sobrang dami pong nag-register. I would say, parang within the past 18 months na ako yung nag-handle ng seminar, eto na yung pinakamadaming nag-register. So, I'll be giving the floor now to you po, sir. Take it away po. Thank you.
Okay. Yeah, good morning, everyone. So without further ado, let us artificial intelligence involves the development of algorithms and computational models that enable machines to process and analyze large amounts of data, identify patterns and relationships, and make predictions or decisions based on that analysis. AI is a branch of computer science that employs machine learning and deep learning algorithms, among others, to learn from and interpolate data to mimic human intelligence. These networks provide predictions by dynamically linking input and output. These networks provide predictions by dynamically linking input and output. These predictions can help create various solutions to both straightforward and complicated situations. In our daily lives, AI-powered technologies are already prevalent. AI is omnipresent nowadays, from mobile face recognition apps to self-driving automobiles. Now, the foundation of AI is the assumption that human intellect can be described in a way that makes it simple for a computer to duplicate and carry out activities of all sizes. Learning, reasoning, and perception are all the goals of AI. AI technology in agriculture has the potential to improve the world. This technology can perform tasks ranging from simple to complex, and the goal of machine is to learn, reason. It aids in the automation of jobs in a variety of industries. The use of intelligence machinery simplifies a variety of tasks. Next. Now, agriculture is a labor-intensive occupation, and with rising population and agricultural production demand, automation is becoming increasingly important. AI significantly assists farmers in components, technologies, and applications. Predictive analytics and improved farm and crop management systems guarantee crop quality and supply. Through satellite photos and meteorological information, businesses determine acreage and track crop health in real time. Businesses can use big data, AI, and ML technologies to anticipate pricing, calculate crop output and yield, and identify pest and disease infestations. They can advise farmers on demand levels, crop varieties to plant for the best profit, the usage of pesticides, and future pricing patterns. AI will be a potent instrument that can help organizations deal with the growing complexity of contemporary agriculture since it dramatically reduces the shortage of resources, productivity, and efficiency. AI technologies are helping people in every sector to overcome conventional obstacles. The growing population is growing at the same time as urbanization is quickening. Farmers need a way to increase output since they are under much pressure to satisfy the growing demand. More people will need to be fed. There will also be a need for innovation in farming because there is a limited supply of rich soil. We must develop strategies to assist farmers in lowering the risk or, at the absolute least, managing them. Global adoption of AI in agriculture is one of the most exciting potentials. Several food producers are now having difficulty controlling the risk and dangers to the crops posed by pests and diseases. These risks are made worse by climate change, monoculture, and widespread pesticide usage. These elements came together to provide farmers with a freeze obstacle. Farms and farmers are under tremendous stress since farming depends heavily on natural resources for the bulk of its good. This stress is exacerbated by the unpredictable nature of rain, lack of laborers, and an annual need for increased yields. This means that the agricultural industry will need to scale up in the coming years. The process of AI adoption in agriculture. It is generally known that the quality of the data accessible to AI determines how effective it will be in solving agricultural problems. AI is seen as a promising technology that might okay. I think I was cut off. The use of farm machinery and efficiency, notably in weed eradication, early disease diagnosis, crop harvesting, and grading, can be revolutionized by combining image classification techniques. Uh, okay. Agriculture using information from precision agricultural software, soil sensors, soil analysis, drones, or even smartphone photographs. AI system can continually monitor the nutrient levels in the soil and compare them to the data repository that has historically produced the highest yields on the specific crop. AI can utilize datasets to examine the environmental implications of applying various dosages and types of fertilizers to find the dose that will have the less detrimental effect while maximizing production. This will help the farm to become environmentally friendly. Now, the role of AI in agriculture. Now, one is yield production. No? Yield production is of high importance for yield mapping, yield estimation, matching of crop supply with demand, and crop management to increase productivity. Uh, an example of this is cost and non-destructive method that ultimately counted coffee fruits on a branch.
Hello, sir. Sir.
They use the
Sir,
ML.
Sir Winston, can you hear me po?
Yes.
Ano po, pwede, third time na po so far ngayon na medyo nag-stick po yung screen mo.
Oo nga.
Siguro po i-off na po muna natin yung camera natin para mas makatulong sa bandwidth.
Sige, sige.
Sige. Thank you, sir.
Ayan. Then another study was conducted on a detection of cherry branches with full foliage using I think BM or GNB. I forgot the acronym meaning of this. Then Amaya et al. Developed a machine vision system for automatic shaking and cutting cherries during harvest. No? The system segments detect all clothed cherry branches with full foliage even when these are inconspicuous. The system aimed to reduce labor and citrus grew under outdoor conditions. No? The study aimed to provide growers with yield-specific information to assist them in optimizing their growth in terms of profit and increased yield. Yeah. Ali and company developed a model for the estimation of grassland biomass based on ANN or artificial neural networks and multi-temporal remote sensing data. Another study was conducted to develop a method for wheat yield production using satellite imagery and save crop growth characteristics fused and remotely sensed red, green, blue, or RGB images, no, which were captured by an unmanned aerial vehicle. Another study was also conducted to develop a method for the rice development stage prediction based on the support vector machine and basic geographic information obtained from the weather station in China. A generalized method for agricultural reed production was also the study regards regional predictions focused on supporting farmers to avoid imbalances in market supply and demand caused or hastened by harvest crop quality. Can you move to the next slide, please? Now, disease detection. One of the most significant concerns in agriculture is pest and disease control in open air and greenhouse conditions. The most widely used practice in pest and disease control is to uniformly spray pesticides over the cropping area. This practice, although effective, has a high financial and significant environmental cost. Environmental impact can be residues in crop products, side effects on groundwater contaminations, impacts on local wildlife and ecosystem, and so on. ML is an integrated part of precision agriculture management where agrochemicals input is targeted in terms of time and place. So a study was conducted to develop a tool for the detection and discrimination of healthy Celebum marianum plants and those infected by smut fungus Microbotrium celebum during the vegetative growth. In the work of Abraham, they developed a new method based on image processing procedure for the classification of parasites and automatic detection of thrips in strawberry greenhouse environment for real-time control. In the work of Chung, they presented a method for the detection and screening of Bacani disease in rice seedlings. They were able to detect the pathogen Fusarium fudicroi for 2 rice cultivars. The automated detection of infected plants increased grain yield and was less time-consuming compared with the naked eye examination. A study was also conducted to develop a new system for the detection of nitrogen-stressed, yellow rust-infected, and healthy winter wheat canopies based on hierarchical, self-organizing classifier and hyperspectral reflectance imaging data. The system can accurately detect these categories for a more effective use of fungicide and fertilizers according to the plant needs. Another study was also conducted to develop a system that automatically discriminates between water-stressed Septoria trici infected and healthy winter wheat canopies. The approach used a least square support vector machines classifier with optical multi-sensor fusion. Moshu also conducted a study that presented a method to detect either yellow rust infected or healthy wheat based on artificial neural network models and spectral reflectance features. The accurate detection of either infected or healthy plants enable the precise targeting of pesticides in the field. In the work of Moshu, a real-time remote sensing system is presented for the detection of yellow rust infected and healthy wheat. Another significant problem in agriculture. Many producers indicate weeds as the most important threats to crop production. The accurate detection of weeds is of high importance to sustainable agriculture because weeds are difficult to detect and discriminate from crops. Again, machine learning algorithms in conjunction with sensors can lead to accurate detection and discrimination of weeds at low cost with no environmental issues and side effects. Machine learning for weed detection can enable the development of tools and robots to destroy weeds, which minimizes the need for herbicides. Another study was conducted to present a new method based on counter propagation ANN and multispectral images captured by an unmanned aircraft system. Again, for the identification of Celebum marianum, a weed that is hard to eradicate and causes major loss in crop yield. They create in that study, they created an active learning system for the recognition of maize or Z-maize as crop plant species and 10 different weed species. The main goal was the accurate recognition and discrimination of these species for economic and environmental purposes. Beans and Fox developed a weed detection method based on SVM, or support vector machine, in grassland cropping. Next slide. The accurate detection and classification of crop quality characteristics can increase product price and reduce waste. In the study of Zhang, they developed a new method for the detection and classification of botanical and non-botanical foreign matters embedded in cotton lint during harvesting. The aim of the study was quality improvement while minimizing fiber damage. Another study was conducted to present a method for the identification and differentiation of Corla fragrant peas into deciduous calyx or persistent calyx categories. The approach applied machine learning methods with hyperspectral reflectance imaging. Another study was also conducted to develop a method for the prediction and classification of the geographical origin of rice samples. The method was based on ML techniques applied on chemical components of the sample. More specifically, the goal was the classification of the geographical origin of rice for two different climate regions in Brazil. No? The results showed that cadmium, Rb, and magnesium and potassium are the four most relevant chemical components for the classifications of samples. Next slide. The goal of species recognition is the automatic identification and classification of plant species to avoid the use of human experts, as well as to reduce the classification time. Grenblatt presented a method for the identification and classification of three legume species, namely the white and red beans, and then the soybean, via leaf vein patterns. Vein morphology carries accurate information about the properties of the leaf. It is an ideal tool for plant identification in comparison with color and shape. Now, in VSU, under the Department of Computer Science, we developed a program that will identify or recognize the variety of sweet potato, cassava variety, and yam variety. These three students who were under me during my stint in VSU, and they were able to produce these softwares that can identify the variety of a certain image of a certain sweet potato using leaf imaging processes. Next slide. Animal welfare deals with the health and well-being of animals with the main application of machine learning in monitoring and animal behavior for early detection of diseases. Dutta et al. Presented a method for the classification of cattle behavior based accelerometers. The purpose of the study was the prediction of events such as the estrus. Estrus is a recurring period of sexual receptivity and fertility in many female mammals, and the recognition of dietary changes in cattle. Pigoreni developed Data was collected using FBG sensors. Mateo et al. Conducted also a study to develop an automated monitoring system based on machine learning for animal behavior tracking, including tracking of animal movement by video cameras for monitoring various activities of animal such as standing, moving, feeding, and drinking. Next.
Hello po. Hi sir, are you still there po? Can you hear us? Okay. So, sa ating audience, let's wait for like a few minutes for
For
with
milk
sir po.
production.
Ayan eh.
In addition, this work showed that milk fatty acids have ideal features to predict the molar proportions of volatile fatty acids in the rumen. Morales et al. Presented a method based on SVM or support vector machine model for the early detection and warning of problems in the commercial production of eggs. The study was also conducted to formulate a method for the accurate estimation of bovine weight trajectories over time based again on the SVM model. The accurate estimation of cattle weights is very important for breeders. The work of Alonso deals with the development of a function for the prediction of carcass weight for beef cattle breed based on SB, support vector regression models, and zoometric measurement features. The results show that the presented method can predict carcass weights 150 days before the slaughter day. Hansen presented a method based on convolutional neural network, or CNN, applied to digital images for pig face recognition. The purpose of the research was the identification of pigs without the need for RFID tags, which involves a distressing activity for the animal, are limited in the range and are time-consuming method. Water management in agricultural production requires significant efforts and plays a significant role in hydrological, climatological, and agronomical balance. The accurate estimation of evapotranspiration is a complex process and is of high importance for resource management and crop production, as well as for the design and operation management of irrigation system. To 2010. Another study was also conducted to present two scenarios for the estimation of daily evapotranspiration from temperature data collected from 6 meteorological stations of a region during the long period. Patel and Dika developed a method based on the extreme learning machine model, feed with temperature data for the weekly estimation of evapotranspiration for 2 meteorological weather stations. The purpose was the accurate estimation of weekly evapotranspiration in arid regions of India based on a limited data scenario for crop water management. Daily dew point temperature, on the other hand, is a significant element for the identification of expected weather phenomena, as well as for the estimation of evapotranspiration and evaporation. A study was conducted again to develop a model for the prediction of daily dew point temperature based on machine learning. The data the weather data were collected from two weather stations. Okay, next slide, please. Soils is a heterogeneous natural resource with complex processes and mechanisms that are difficult to understand. Soil properties allow researchers to understand the dynamic of ecosystems and the impediment in agriculture. The accurate estimation of soil conditions can lead to improved soil management. Soil temperature alone plays a significant role in the accurate analysis of the climate change effects of a region and the economical conditions. It is a significant meteorological parameters controlling the interactive processes between the ground and the atmosphere. In addition, soil moisture plays an important role in crop yield variability. However, soil moisture measurements are generally time-consuming and expensive. So a low-cost and reliable solutions for the accurate estimation of soil conditions can be achieved with the usage of computational analysis based on ML techniques. Coppersmith presented a method to accurately evaluate soil drying with evapotranspiration and precipitation data. The goal of this method was the provision of remote agricultural management decisions. Morelius et al. Developed a method for the prediction of soil condition. The study presented the comparison of four regression models for the prediction of soil organic carbon, moisture content, and total nitrogen, or TN. The use of visible near infrared or VISNER spectrophotometer to collect soil spectra from 140 unprocessed and wet samples, the top layers of certain soil types from an arable field after the harvest of wheat crops. They concluded that the accurate prediction of soil properties can optimize soil management. Another study was conducted to develop a method based on self-adaptive evolutionary extreme learning machine model and collected daily weather data for the estimation of daily soil temperature at 6 different depths in 2 different climate conditions. The aim was the accurate estimation of soil temperature for agricultural management. Johan presented a novel method for the estimation of soil moisture based on ANN models using data from 4 sensors on a no-till chisel opener. Next slide. The challenge of selecting suitable crops with improved yields is critical, as yields can vary depending on numerous conditions such as weather, soil quality, water access, and pests and diseases. AI and machine learning technologies are being increasingly used in crop selection and yield management in agriculture. These technologies are particularly useful in crop breeding and genetic improvement by analyzing genetic data from different crops and using ML algorithms to identify key traits associated with yield and other desirable characteristics. Plant breeders can develop new crop varieties that are better adapted to specific environmental conditions and produce higher yield. Automation technologies such as robots are being increasingly used to improve crop yields by reducing labor costs and improving efficiency in various agricultural tasks, including spraying, herbicides, removing weeds, and harvesting fruits and vegetables. Robots such as the Berry 5 robot are designed to automate the harvesting of strawberries, which is a labor-intensive and time-consuming process. The robot uses computer vision and ML algorithms to identify and pick ripe strawberries at a faster rate than humans can. This can help farmers to reduce labor costs and improve their yields by ensuring that more strawberries are harvested at the optimal time. Similarly, robots such as the RoboCrop are being developed for specific agricultural tasks such as pruning flowers on strawberry plants. On strawberry plants. Furthermore, the aim is processing robot being developed for picking ripened strawberries using computer vision and ML algorithms to identify and pick the strawberries, including reducing labor costs and improving the speed and efficiency of the harvesting process. The National Physical Laboratory in London developed robots that use computer vision and ML to identify water and nutrient levels, control weeds, and perform sorting and packaging. Researchers have developed a method for measuring plant water retention using image processing techniques in combination with other software for the purpose of using X-ray to study unsaturated Houston sand and its water retention behavior. A complete configuration and setup were created. A step-by-step technique for holding sufficiently high-quality reconstruction that allow the three phases of the material, the grain, water, and air, to be differentiated was also provided. The visualization and characterization of the three stages inside the specimen were made easier using picture post-processing. This made it easier to create a measuring map that encompasses the whole specimen field. Robot
No, sir.
study was conducted to apply agroecological breeding methods such as the maize legume intercropping, and the post-pull irrigation are used to forecast maize production. This study also reported that the scale-up MLI and PPT system improve productivity in sustainable farming. Next slide. IoT or Internet of Things in smart farming. Another aspect of smart farming is the climate condition based irrigation. A certain project was created to aimed at improving plant production. It has been developed to increase efficiency in plant production while controlling the excessive use of irrigation, water, and nutrients. Microsoft has also developed an AI-based sowing application that provides recommendations such as the optimal sowing period, preparing the land for cultivation, etc. The model by mobile phone apps uses remote sensing data from geostationary satellite images to predict crop yields through every stage of farming. To determine the optimal sowing period, the moisture adequacy index was calculated. The input data includes historical sowing area, production yield, and weather. The app sends sowing advisories to participating farmers on the optimal date to sow. The farmers do not need to install any sensors in their field or incur any capital. The farmers do not need to install any sensor in the fields or incur any capital expenditure. They just need a feature phone capable of receiving text messages. It is imperative that smart solutions are being developed for global food safety and security, the sustainability of food consumption, and the well-being of society. Likewise, reduces losses, and shelf life extension of food products for global food security. Low altitude spectral imaging for identifying pest infestations, nutrient or moisture deficiencies, and more, as well as computer is an example of smart farming. Smart farming is one of the biggest methods or systems of precision farming. Uh, Precision farming involves the precise number of inputs, such as soil, water, or fertilizer, to be distributed in accurate time and at accurate place, such as weed control. Trimble Agriculture has developed a system called Weed Seeker Spot Spray, an innovative solution for efficient and targeted weed control by using sensors to detect the presence of weeds and a spray nozzle to deliver a precise amount of chemicals. The system can help reduce the use of herbicides and minimize the environmental impact of weed control. This system can be mounted even on traditional spraying machines with some modification and is most effective in areas with intermittent growth of weeds. Yield technology and the Bush have developed a range of technologies that can be used in precision agriculture to optimize crop yield and reduce resource waste. These technologies include drones, computers, data analytics, and robots, among others. Role of AI in food processing. The proper arrangement and packing of food products are among the challenging tasks and time-consuming processes in the manufacturing sections of the food industry. Food packing has four vital rules: protecting the food, displaying the product, ensuring sanitation, and transportation ability. It protects the food from the damage caused by biological, chemical, and physiological reasons throughout the completed food logistics system. The visual appearance of the package helps consumers to judge the quality of food, and it is the first impression of the product. Therefore, effective packaging is an essential part of the food manufacturing sector. AI and ML are increasingly being used in the food packaging industry to improve the design, production, and functionality of packaging materials. AI and ML technologies are being used in the food packaging industry to improve packaging design. A study was conducted to apply a packaging design model based on deep convolutional generative adversarial networks, or DCGAN. A packaging design image can be enhanced using visual communications technology, resulting in better visual communication ability, a higher degree of image information fusion, and an improved packaging design effect. Moshiri and Tendi develop an automated grading of tomatoes using artificial intelligence. Intelligent tools such as robotics and drones can also perform a critical role in reducing the packaging cost significantly. For instance, robotics can be used to automate the packaging process, reducing the need for human labor and improving the speed and efficiency of the process. Robots can be used to sort and inspect food products and ensure that they are properly packaged and meet quality standards. Next slide, please. AI-based system can incorporate a variety of technologies such as a laser technology, X-ray systems, high resolution cameras, and infrared spectroscopy. To evaluate the parameters of products at the input level, these technologies can help identify defects, contaminants, and inconsistencies in products, enabling intelligent decision-making and improving overall product quality. However, the inconsistent product homogeneity can be a major drawback for sorting methods that rely on input-level evaluation. Inhomogeneous products may result in inaccurate sorting decisions, leading to increased waste or lower product quality. To overcome this challenge, some sorting systems use multiple sensors or technologies to assess product quality and identify defects from multiple perspectives. Additionally, the machine learning algorithms can be trained to recognize patterns and variations in product properties, helping to improve accuracy and consistency in sorting decisions. Tomra, the global provider of advanced collection and sorting systems, has developed an AI system that can efficiently perform the sorting task with 90% efficiency. Industries have gained some advantages such as increased production, high quality yields, and reduced labor costs by utilizing such systems. It has been reported that segregation and arrangement issues can be reduced by 5 to 10% in potatoes. In the apple processing industry, deep learning, a subdivision of machine learning, and a subfield of AI help to categorize apples with the help of datasets through pattern recognition and decision making. Similarly, a deep convolutional neural network assists in identifying the type of apple with the support of the concurrent version system. The deep learning model was trained on the data from image processing, apple detections, and ripeness classification. The classifier can achieve the best results, that is the ripeness class of an apple from a given digital image. Okay. Contamination by foreign objects causes major issues, including food recalls, rejections, re- re- rejection by consumers, harm to customers, and a fall in brand reliability. Foreign matters, including insects, glass, metal, or rubber, may accidentally enter the food or packing materials during food processing, handling, or preparation. Although the magnitude of risk associated with foreign matters depend on the size, type, clarity, and hardness of the object. The consumption of food contaminated with such object could lead to choking or other complications. As identification of such contaminants with the unaided eye is tough. No? AI and ML technologies can perform an important role in their detection by analyzing images of the food products to identify uncontaminated food products. The algorithm can then analyze images of the food products in real time and identify any foreign objects that may be present. Shimon Nomura and company applied a cylindrical tactile image sensor for detecting foreign objects in food based on differences in hardness. Small, hard foreign bodies that were sub-millimeter in size and mixed in with soft food could be successfully detected by using a reflective membrane type sensor surface with high sensitivity. Through investigation to find shell pieces left on the surface of a raw shrimp and bones left in fish fillet, the effectiveness of the suggested method was confirmed. Next slide. As new product development in the food industry relies on consumers' perspectives, data collected by the various decision-making systems are useful in the launch of new products. By analyzing the data gathered by the system, the ML-based module could answer the question, what exactly the consumer are looking for, and make proper decisions. One of the multinational companies has installed automatic vending machines throughout the USA for delivering soft drinks in the machine could be analyzed by the language no, machine learning module and deep learning algorithm for the development of new products. One such example is the Cherry Sprite launched by the company. It has also been proposed that in the upcoming decades, many of the food industry will benefit from the ML-based decision-making system for the launch of new food products. A biotechnology company has launched the world's first bioactive peptide through AI technology. A sport nutrition ingredient is a unique peptide network derived from rice protein for alleviating inflammation via modulating cytokine responses and improving immune activity. The company has become the world's first company to demonstrate the potential of AI in improving human health. Another US-based IoT-focused technology company has introduced AI-powered home cooking sidekick, a web and mobile applications that integrates with smart kitchen assistant Hello Egg to fully automate kitchen needs. The home assistant is powered through voice technology to recommend a diet plan on the preferences of an individual. This can also manage the pantry, categorize shopping cart, exhibit video recipes, and assist in the delivery of groceries. The role of sensory panelists employed in the food and beverage industries aims to sensory evaluate the new product based on the flavor preferences of the chef. Unfortunately, it is difficult to predict the perception and preferences of the target group. This led industries to develop a robust methodology for measuring and predicting consumer preferences through an AI-based gastrograph system, which uses ML and predictive algorithm to understand market preferences. Next slide. Pieces of machinery and processing tools used in food processing industry must be cleaned regularly for proper maintenance. AI-based systems such as cleaning in place and clean out of place systems assist the food industry to ensure hygiene and maintain products quality of high standard. For its implementation, various cameras and sensors are installed to carry out the task. Currently, a European company specializing in providing cleaning solutions has introduced SOSIP or cleaning in place or a self-organizing cleaning in place system to autonomously optimize the cleaning process for food manufacturing equipment using AI technology. SOSIP employs ultrasonic sensing imaging methods and optical fluorescence methods to assess the number of food particles and microbial debris that are present inside the equipment. The SOSIP system works by using sensors to scan the inside of the equipment and create a real-time image of the surface. This information is then used to determine how much cleaning execution of all food logistics activities. To monitor every stage of the process, for instance, from cost regulations to resource management, AI is being employed AI is being employed. It manages and predicts the passage of positions from where they are grown to the place where consumers gather them. One company provides integrated AI-enabled solutions for the retail industry. This solution can help to optimize various aspects of retail operations, including transportation, billing, resource management, and inventory control. The system can improve the retail industry using AI algorithms to optimize packaging and improve shelf life. By analyzing data on products' characteristics, environmental conditions, and other factors, AI algorithms can help to identify the optimal packaging materials and designs to improve product quality and extend shelf life. There will be a need for more contributions that make use of a variety of data sources to realize the goal of an expanded agri-food supply chain that involve more stakeholders and the whole supply chain lifetime. Additionally, to complete the loop in sustainable agri-food, the extended AI support for agri-food needs to increase the use of contextual information, food consumption, and food waste reduction. Next slide. Next slide. I think that. Now, we're about to end. Uh, Borrowing from the conclusions of Taniha et al. And their paper, they say AI has the potential to revolutionize the food and agriculture sector by improving efficiency, increasing productivity, and promoting sustainability. However, the future of AI in the food and agriculture sector also raises some concerns. For example, there are concerns about the potential for AI to increase inequality and reduce jobs in rural areas. A major constraint is the high cost of implementing AI systems. AI requires significant investment in hardware, software, and training, which can be prohibitively expensive for small and medium-sized businesses. Additionally, there are concerns about the reliability and accuracy of AI systems, particularly when it comes to making decisions about crop management and food safety. Smart robotic farming and factories are just some of the how AI and ML are being used to improve efficiency, productivity, and stability in agri-food industry. The future of the agriculture and food industry is likely to be shaped by AI and ML technologies with a range of potential applications across farming, pest management, food processing, packaging, quality control, shelf life extension, and supply chain management. While there is a lot of potential for AI to revolutionize the agri-food sector, making it more efficient, sustainable, and innovative, it also raises important sustainability of AI will depend on a range of factors, including the development and deployment of AI technologies, the policies and regulations that govern their use, and the way in which society adapts to the changes that AI brings. The sustainability of AI encompasses a range of environmental, social, and economic factors. Several key considerations that need to be considered when it comes to the sustainability and future of AI. There is a need to address the skills gap and to ensure that there is a sufficient pool of talent to develop and deploy AI systems sustainably and responsibly. This requires investment in education and training programs that equip individuals with the skills and knowledge needed to work in AI. While there are still challenges to overcome, such as data privacy concerns, high cost, ethical issues, and the need for specialized training, the future looks promising for AI in this industry. As more and more farmers adopt AI-powered technologies, one can expect to see significant improvements in food production and distribution in the years to come. Future, future work could include comparing different ML algorithms for predictive performance and operational process in the agri-food industry. AI in agriculture has the potential to we know it. From precision farming to predictive analytics, the benefits are clear. However, challenges like high cost and integration issues remain. And that ends my presentation. Now it's 11:20.
Thank you so much, Sir Winston, for this interesting and comprehensive presentation on how we can utilize AI in agriculture and the food industry. So, ayun, since we have inclement weather on Sir Winston side, and hi Sir, welcome back sa welcome back po. Na-miss namin yung
Yeah.
yung visuals mo for the past hour. So, Sana po okay pa kayo diyan. So anyway, we will be proceeding in a bit to our Q&A, pero we will be limiting it kasi medyo it's a bit late, and also as consideration na din kay Sir Winston kasi binabagyo na sila. So yun, also reminders, I already posted the attendance sheet around 11:50 something. So nakapin na po yun sa comment section, and if it doesn't work on your phone, you can use your PC para mabuksan kasi there have already been answers sa attendance sheet natin. So nag-work naman po siya. So yun, sir. So I'll be okay. We have two questions here from our DA bar colleagues. Let me just get the questions. Okay. So eto po, sir, magandang tanong po 'to. How can AI be made affordable for smallholder farmers daw po?
Thank you for that very nice question. And I think that is the concern, no? Because as mentioned, AI implementation of AI in agriculture is quite expensive, and our small farmers definitely cannot afford it. So high investment costs for sensors, drones, and AI-powered machinery are a significant barrier, creating a risk that AI benefits only large-scale agribusinesses. Making AI affordable for smallholder farmers requires a strategic shift towards low-cost technology, collaborative financial models, and user-friendly, localized, offline-capable applications. Key strategies include using existing smartphone technology, implementing pay-per-use models, leveraging farmer cooperatives for resource sharing, and providing government subsidies for AI adoptions. So I think I hope
So
I answered your question.
So mga low cost, and yung again, when we hear AI po kasi it usually comes off as intimidating kasi sobrang advanced. Pero po, as you discussed earlier, AI, kahit yung internet lang, it's already parang yung IoTs, yung Internet of Things, it's already counted as AI po, 'di ba? Or
Oh,
nasa umbrella term na siya. So we don't need to be very advanced level talaga sa technology on the
yes.
matter, as long as we can
Yeah, for
connect to the
example, for
internet.
image processing, we can use our smartphones because the
Mhm.
camera of the smartphone is sufficient enough to capture
Mhm.
images for processing.
Mhm. And also, sir, as you mentioned, I think it's good na mag-collaborate yung
Yeah,
mga
correct.
smallholder farmers, so they can like bumuo sila ng farmer cooperatives and association so that it would be easier for them to connect with funding or support from the government and
Yeah,
other
that's right.
NGOs or
That's right.
entities. Thank you, sir. So on to our next question. Okay. How can AI models be more robust, be made more robust across varied conditions?
Yeah. Yeah, agriculture is highly variable. The climate, the soil, and geography, making it hard to transfer AI models from one field to another. So developing models with higher generality is a priority. No? So meaning, yeah, of course, we cannot just copy or replicate what the AI technology from one country to us, but we need, of course, to develop. No, we are already capable, no, because we have the IT and computer science people or graduates that can implement and take note that the data, the climate, the soil, and geography are not the same, no, in different areas. So that's why we have to replicate by ourselves, no, and use our local data in training this uh, machine learning software.
Thank Thank you, Sir Winston. So, yun naman po yung kagandahan ng ating technology is that hindi siya walang kahit isang tao or isang grupo na nagmamay-ari lang ng ating technology. So, we can all contribute to the pool of knowledge. So, as long
Yeah.
as we have our own technologies as simple as phones, kaya nating makapag-share ng data to the big data. And the big data would be able to help us generate more location specific information which could help the farmers in their local situations.
Yeah. So
So
the,
far, sir, meron po ba tayong parang Um, may certain organization or bodies po ba na parang sila yung nagko-collate ng data on this na based on in the Philippines? Or as long as
well,
they upload it to the internet or may certain platform po ba for this knowledge sharing or yeah.
yeah, I think the USTs are already they are already on AI or machine learning. But SOCs that are offering computer science or IT, uh, maybe what we can do is maybe support I don't know, research on AI for agriculture. So sa undergrad ng computer science, marami ng in fact in BSU we have already a number of thesis or software being developed for machine learning. Yeah, and I think I
So
mentioned that
san
already. No? Yeah, yung sweet potato variety recognizer, then yung cassava, and yung sa OB, no?
okay. So this is really thank you, Sir Winston. So this is related to Okay, this is related to what was discussed just minutes earlier. So yun. So government support, we have the OST, of course, DA, kami sa DA bar, we support research in agriculture and fisheries. So including
Uh,
AI, of course.
yeah,
We funded several na on this. And yun, as mentioned by Sir Winston, yung mga state universities, yung may mga computer science degrees or IT related degrees, they have their own systems na. So hopefully po sana mas in the future parang mas mag-communicate pa sila as a
connect.
whole.
Yeah.
So parang may database or master class tayo on this. So I think
Mhm.
that would be a good thing. And this one po, sir. So this is from Project Tiwala. Okay. Agriculture sensors are often exposed to extreme heat and mud in Isabela province. How does the machine learning model handle noisy or garbage data from a malfunctioning sensor to ensure farmers don't get the wrong advice?
Uh, yes, so I think the solution to this is, we have to include this noisy or garbage data in the training, no, in the training of the ML, no, of the software, no, because we have the training and then the testing, no, testing it could be the actual implementation, na. But sa training ang data that will be used for training should include noisy or garbage data because yeah
So, sir, medyo humina po signal mo, sir. Sir? Okay, hintayin po natin saglit si sir. Okay, so while we're waiting for yun, na umayos yung signal ni sir. So may question po dito about weed control using drones. So I've read sir's paper. So parang meron na pong ano dito, meron na po actually atang ginawang weed control using drone, but I think it started with imaging muna. And yung actual weed control, it had ginamitan siya ng IoT. Pero i-try ko po 'tong erase later on kapag bumalik si sir, pero ano, we'll be prioritizing other questions muna. Pero sana po bumalik muna si sir ngayon. Sir, if you can hear me, can you try to turn your camera off po muna? Wala na sa studio. Okay, nakabalik na si sir. So, nakabalik na po si sir sa studio. Hintayin po natin siya. Hi, sir!
Sorry. Photo na naman.
Okay, sir. So, eto po yung question kanina na hindi ko na po alam exactly kung saan ka naputol dito. But the last thing that I remember you mentioned was the noisy or garbage data.
Yeah, well, one solution to that problem is we have to include the this garbage data uh, during the training of the ML, no? We include or perhaps we can tweak the software to be able to to identify outliers, no, outliers, no, because the data that from this garbage data maybe extreme data, no, and that can be detected in during the training.
Okay.
Mm.
So, train the system to detect. Train the
Yeah.
system to register the noisy and garbage data para mas ma-identify na later on.
Uh,
So, thank you, sir. We'll be moving on to the next question po. So, this one is a good question. So, from Sir Vince Ilagan, what risks do we face if we do not adopt AI in agriculture over the next 5 to 10 years?
well, well, of course, if we do not adopt AI, then we will still be in the same. I don't know. I mean, we would not expect, yung yield, yung yeah, increase of yields, no, for example, no, or we cannot attain that, if we do not, no, for example, ang control of pests and diseases. If we still use the manual way of doing it, then of course we cannot prevent, the infestation. So I think, yeah, that would be the scenario if we do not adapt. No, we would still be on the same uh, sana.
So, thank you, sir. So, to add din po, kasi nabasa ko din to sa, nabasa ko din to dun sa reference na binigay sa akin ni sir kahapon. So, it's not a risk per se, but more of we won't be able to catch up with the demand of the population because the population is increasing, but our resources are just the same. We have the same plot of land na very, very limited. So it's a challenge for the agriculture and the food sector to actually be able to provide to the booming population, which happens exponentially. So yan, and of course, include na po natin yung climate change, and of course, the pest diseases are getting more resistant na sa ating mga ginagawang ginagawang solution sa kanila before. If it used to work, then hopefully not, but yeah, there's a big possibility that it might not work as good as before. So, ito po. Mm. Okay, ito po, sir. So, okay. So, kailan po ba ang full-blown implementation using AI technology from primitive way of farming on a national level? So, medyo mahirap po 'tong sagutin. Pero
Oh,
go po, sir.
well, I cannot answer that because I'm just an ordinary. Yeah, well, I'm just technical, but on the ano, on some policy, I'm not. Uh, it's not my level.
Totoo sir, mahirap po talaga siya sagutin. Pero ako po personally, yung take ko dito and as influenced na din ng perspective ng DA and ng DA bar is that we really need to collaborate so that we can, ano yun, parang we need to collaborate para mas maayos natin yung what's that? Yung infrastructure natin. So not just limited to the IT infrastructure as well as the support systems ng ano na pwedeng ma-provide ng bawat agency or ng bawat organization. And at the same time, dapat mas maging ano siya yung matanim yung foundation niya sa policy level. So ito po sir. Ito po. So this is from Sir Vince. Again, how do we ensure AI promotes sustainable intensification, not just higher yields?
How do we ensure AI promotes sustainable intensification? Can you expound more on what do you mean by sustainable intensification?
Okay, sige, balikan po natin siya. Ito po si Miss Josephine Tolentino Garcia. This was asked before nung nawala ka po. So, weed control daw po using drone. I think nabasa ko po to dun sa paper mo kahapon.
Sige, weed control using drone.
Okay.
In the local settings in Farmers Hill, meron na po tayong pilot project regarding. Again, yeah, well, I do not know with BAR if we have funded already some projects on AI. I think yung on-site nutrient management, I think that's already, I don't know, and I think many regions are already doing that. No? In situ, I think in situ nutrient management. No, it's about soil nutrients management, and that's already part of the that an AI. No, and I saw that there are already a number of regions that are implementing that.
Okay. So SSNM nutrient, is it the SSNM nutrient
Yeah,
expert
I
po,
think
sir?
that.
Ayun. Anyway, sir, thank you po for answering these questions. Now we'll be on to our last two questions kasi magto-12 na din. So, yun, yung last second to the last question po, ano po yung message or words of wisdom nyo to the researchers in the agri-fishery sector? Hello, sir.
Yeah. So, naputol again.
Naputol po ulit. Ayun po. Siguro po pagsamahin ko na po ito ng tanong. So ano po yung message or words of wisdom mo for the researchers and in the agri-fishery sector tapos sa farmers and fisher folk?
Well, first is yung there should be a collaboration between the technical, meaning the agriculture and the IT or computer science, especially in a state university setting, because right now, as I observe that the agriculture are just doing their own research without tapping the talents of the more technical computer science or IT, no? So, ang nangyari, kanya-kanyang ano na ng research. So, and we know nga yung agriculture side ng application, walang kanalis-nalis ang computer science kaya wala naman siyang agriculture na na subject. So I suggest that maybe yeah, just like what other countries, no, in India, in the US, there is a collaboration, no, between agriculturists and the IT people doing research on machine learning. Yeah, specific to a certain crop or specific to a certain agricultural application. So that's I don't know, that's my first suggestion. And the second is, the national the national yeah, like bar, no, that they are funding research. So maybe to encourage, no, to encourage this.
Sir, hintayin po natin uli si sir. Siguro last na talaga to before we read the certificate. Yun sir, nawala ka po uli. So, yung hali mo pong sinabi na nag-register sa amin is parang related sa bar, I think, to encourage.
So yun yun nga, para ma-encourage for these researchers, no, yung collaborative research with the computer science and agriculture, then maybe to provide incentives to come up with research proposals related to AI applications in agriculture.
Thank you, sir. Last na po, sir. Just make it brief po kasi parang napuputol-putol ka na po. Ano po yung message mo sa ating farmers and fisher folk? Just brief message po.
Well, I cannot think of. Well, of course, we have to, go with the flow, no? Meaning, what the other countries are already doing, maybe we have to, I don't know, we have to follow or replicate what they have been doing, so that we can improve our life, no? So let us not just be contented of what we have produced or what we have, but perhaps look at access this technology, because these are actually it's really implementable in our settings.
So thank you, Sir Winston. So generally, sinabi ni Sir Winston is collaboration between IT and agriculture, and of course for the farmers and the fisher folk on ground to be open to trying these technologies kasi it's for everyone naman of us. Now, thank you so much, Sir Winston, for generously sharing your expertise and passion to the public. So we'll be finding a way to hand you the certificate. So, sir. And I'll be reading the certificate citation now. The DA Bureau of Agricultural Research awards this certificate of appreciation to Mr. Winston M. Tabada for sharing his invaluable knowledge during the DA Bar online seminar series, Artificial Intelligence in Agriculture and the Food Industry, held on the 5th of February 2026 via StreamYard and DA Bar Facebook page, given this 5th day of February 2026 in Diliman, Quezon City, signed by DA Bar OIC Director Sir Joel H. Lales. And this concludes our online seminar. Salamat po, Sir Winston.
Thank you.
And
Thank
we are looking forward to the nationwide integration of artificial intelligence with our agriculture and food industry. Sana nga po mangyari siya in the future and maging well supported by the different sectors. And again, reminders po yung attendance sheet. It's up until 12 noon. And yun, if you have questions on the seminar or other things, just message the A-Bar Facebook page. So follow niyo po yung Facebook pages namin. It's facebook.com/DABAR official or DA Bureau of Agricultural Research. And check niyo po, follow niyo yung YouTube account namin to revisit past seminar episodes to learn more about our online seminar series that we hold monthly and other activities of the A-Bar that might benefit or interest you. So salamat po, Sir Winston, and thank you din po, Aria, for collaborating on this seminar episode, and salamat po sa ating viewers for actively participating in our knowledge exchange. Sir, may gusto ka po bang sabihin or pasalamatan?
Well, thank you for inviting me, as a resource person on this topic. And again, also, well, of course, I know that I was posed by the ARIA, no? I forgot. Yeah, the ARIA, that really, actually the first one that approached me to speak on AI. Well, I thank for this, and I think they made really an effort to reach out bar so that we can have this seminar. Well,
Thank you
of
so
course.
much po, sir. Sige po, sorry, go.
Okay, that's all.
So salamat po, sir, kung wala na po, salamat po sa pagpa-unlock sa amin. And I know it's the situation in Region 8 and the eastern part of the country, so eastern and southeastern part of the country, medyo mahirap na ngayon. At salamat po sa pagpa-unlock pa rin sa amin. And I know the signal has been very challenging on you. And of course, the environment, physical environment nyo. So, ingat po kayo, sir. So, stay safe and dry.
Yeah.
So, everyone,
Yeah.
palakpakan at pusuan po natin si Sir Winston. Very much well-deserved.
Thank
At
you.
dito po
Thank you.
nagtatapos. Thank you, sir. And dito po nagtatapos ang ating free online seminar for today. Ako po si Tin. Isang mapagpalang umaga po sa ating lahat. And with the bagyo, please stay safe and dry po, everyone, including our properties, livestock, and everything. Kita-kita po tayo sa sunod na seminar at sa mga susunod pa. Thank you so much, sir.
Thank you. Bye.
Ingat po.
The rising global population threatens food security, as the increased demand for food puts pressure on our agricultural resources and production systems. This increased demand intensifies problems like land degradation, water scarcity, climate change, and competition for arable land, making it harder to provide nutritious food for everyone, especially in areas already experiencing food insecurity. Focusing on innovative technologies and sustainable agricultural practices, these challenges can become valuable opportunities that can drive economic growth and technological advancement. Research for Development, or R4D, plays a pivotal role in addressing the challenge of food security. In the Philippines, an organization is emphasizing the transformative power of technology to drive the sector towards its optimal potential through Research for Development, or R4D. The Department of Agriculture, Bureau of Agricultural Research, or DA-BAR. Supported by various executive orders and Republic Act 8435, also known as Agri-Fisheries Modernization Act, or AFMA, DA-BAR is mandated to ensure that all agricultural research is coordinated and undertaken for maximum utility to agriculture. DA-BAR coordinates, integrates, funds and manages the R4D system in the country to optimize its use for the sector. It is envisioned to be the lead R4D coordinating agency, promoting a technology-empowered agriculture and fisheries sector that contributes to inclusive growth. To ensure that research leads to desired results and long-term impact, DA-BAR follows the R4D Impact Pathway Framework. It assists DA-BAR in planning, monitoring, and evaluating the effectiveness of R4D projects under rice, corn and cassava, livestock and poultry, fisheries and aquaculture, organic agriculture, climate change, biotechnology, support to technology commercialization, agri-fisheries technology business incubation, and scale-up, thereby connecting research outputs to outcomes and societal impact, aligning efforts with industry goals, and generating meaningful, measurable change. It is DA-BAR's responsibility to ensure that suitable technologies and interventions are promptly accessible for the sector's utilization. However, DA-BAR cannot accomplish this alone. It needs capable partners in cascading these R4D outputs and outcomes that will advance technology-driven agriculture and fisheries sector. Collaboration is the backbone of research, and seamless integration of interdisciplinary expertise and resources is crucial for achieving common goals. By partnering with DA-BAR, we attain greater productivity in a cost-effective manner. Like the age-old adage, the sum is greater than its parts. Here at DA-BAR, we firmly believe that the power of collaboration has the potential to unleash a magnitude of possibilities beyond measure. We offer funding opportunities that can substantially improve the effectiveness and breadth of research endeavors. We facilitate networks and linkages to enhance opportunities to leverage expertise and resources. And more significantly, we serve as a hub for invaluable knowledge exchange, harnessing emerging and innovative technologies to tackle pressing sectoral challenges and global issues.